Your refrigerator is running right now. It has been running every single day since the day it was delivered, every hour of every day, 12 months a year, for every year you have owned it. It is the one appliance in your home that never stops, never rests, never takes a day off. And right now, today, it is consuming between 30 and 50% more electricity than it was designed to use. Not because it is broken, not because it is old, because there is a component on the back or underneath your refrigerator that has never been cleaned, never been maintained, and has been quietly strangling your compressor's efficiency every single month since the day it left factory floor. That component is your condenser coil. And what has built up on it, dust, pet hair, kitchen grease lint, is acting as a thermal blanket wrapped around the heart of your refrigerator's cooling system. Your compressor is working 2 to 3 times harder than it should to push heat through that blanket. Your electricity meter is counting every wasted watt, and your appliance maker designed the access panel to make sure you would never think to look. There is a $3 fix, 2 copper fin comb clips available at any HVAC supply store. You clean the coil in 12 minutes. You clip the fins back into alignment. Your compressor drops back to its rated current draw within 1 full cooling cycle. The reduction in your electricity consumption is immediate, measurable, and permanent as long as you maintain the coil twice a year. Energy Star testing data confirms efficiency losses of 15 to 35% from dirty condenser coils. Your appliance maker confirmed it in the engineering specifications they never put in your owner's manual. If nobody has ever told you to clean your condenser coil, what you are about to learn will change the way you think about every appliance running in your home right now. This is Forbidden Saving. We dig up what the industry buried. If this kind of knowledge matters to you, hit subscribe and turn on notifications right now, because what we open in this vault gets heavier every single video. The bell is the only way to make sure you never miss it. Now, let me show you exactly why appliance manufacturers spent 40 years making sure this page was removed from your owner's manual. The United States household appliance industry generates over $50 billion in revenue every single year. Refrigerator sales alone account for over $15 billion annually. The average American household replaces their refrigerator every 12 to 15 years. At an average replacement cost of $1.200 to $2.800, that replacement cycle represents an enormous predictable revenue stream for every appliance manufacturer on the market. That revenue stream depends on one foundational assumption, that your refrigerator will fail on schedule. A refrigerator compressor running at rated efficiency drawing rated current, operating within its designed thermal envelope, lasts 20 to 25 years without major failure. Every appliance engineer who ever designed a refrigeration system knows this. The engineering lifespan is 20 to 25 years under proper operating conditions. A refrigerator compressor running against a dirty condenser coil, drawing 35% excess current, operating at elevated temperature every single hour of every single day, lasts 11 to 14 years, sometimes less. The difference between a 2-2-year compressor and a 1-2-year compressor is 1 decade of replacement revenue. 1 additional refrigerator sale per household per generation, multiplied across 130 million American households. That is a number that appliance manufacturers calculated very carefully when they decided that condenser coil maintenance instructions did not need to appear in the owner's manual. In 1987, every major refrigerator manufacturer sold with a printed maintenance card attached to the back of the unit. The card included condenser coil cleaning as a recommended 6-month maintenance task. By 1997, the maintenance card had disappeared from every major brand. By 2005, the condenser coil access panel had been redesigned on most models to require a screwdriver and a flashlight to reach. The coil did not become less important between 1987 and 2005. The revenue model did. The year was 1929. In Dayton, Ohio, inside the engineering laboratories of Frigidaire, a division of General Motors, a refrigeration engineer named Charles Kettering was solving a different problem entirely. Kettering was not thinking about dirty coils. He was designing the first mass-market electric refrigerator, intended to replace the icebox in American homes. His engineering team was obsessed with one challenge: making the compressor reliable enough to run continuously for years without mechanical failure in the hands of homeowners who had never maintained a mechanical appliance in their failures. Lives. Kettering's solution was elegant. He designed a sealed compressor system with a condenser coil mounted on the exterior of the cabinet, where natural convection airflow would carry away the heat the refrigeration cycle rejected. The coil was accessible, intentionally accessible. Kettering's original design specifications noted that the condenser coil required periodic cleaning to maintain heat rejection efficiency, and that reduced heat rejection efficiency would increase compressor operating temperature, shorten compressor service life. His refrigerators came with a cleaning brush attached to the back panel. The instructions were printed directly on the cabinet interior. Clean the condenser coil every 6 months, the same way you change the oil in your car. Frigidaire refrigerators from the 1930s and 1940s lasted 30 to 40 years in regular household service. There are documented examples of 1940s Frigidaire units still operational today. Kettering's maintenance-forward design philosophy produced appliances that outlasted the households that purchased them. Then, in 1955, something changed in the appliance industry that had nothing to do with engineering. A business consultant named Bernard London had published a paper in 1932 titled "Ending the Depression Through Planned Obsolescence." London argued that manufacturers should deliberately design products with limited service lives to ensure replacement purchases and sustain economic activity. His paper was largely ignored during the Depression. But by the mid-1950s, as American consumer culture reached full post-war expansion, his philosophy had quietly become standard practice in appliance boardrooms from coast to coast. The first casualty was the maintenance manual. If a consumer maintains their appliance correctly and it lasts 25 years, they buy one refrigerator in their adult lifetime. If they never maintain it and it fails at 12 years, they buy two. The mathematics of planned obsolescence made condenser coil maintenance instructions an obstacle to revenue. By 1965, the cleaning brush had disappeared from refrigerator packaging industry-wide. By 1975, condenser coil maintenance had been removed from every major brand's printed owner documentation. By 1985, a generation of American homeowners had grown up, never knowing their refrigerator had a condenser coil that required any attention at all. Charles Kettering died in 1958. His original engineering philosophy, build it right, maintain it properly, make it last, died with the maintenance card that disappeared from the back of the refrigerator the decade after he was gone. Here is exactly what your condenser coil does and why what has built up on it is costing you money every single hour. Your refrigerator works by moving heat, not by creating cold, but by extracting heat from the interior cabinet and rejecting it into the room air outside. The refrigeration cycle uses a compressor to pressurize refrigerant gas, which causes it to release heat through the condenser coil on the outside of the cabinet. That heat transfers from the coil fins into the surrounding room air through convection. The refrigerant then flows to the evaporator coil inside the cabinet, where it absorbs heat from your food, and the cycle repeats. The efficiency of this entire cycle depends on one critical variable: how effectively the condenser coil transfers heat into the surrounding air. Heat transfer between a solid surface and air is governed by a fundamental equation in thermal engineering. The rate of heat transfer equals the heat transfer coefficient multiplied by the surface area multiplied by the temperature difference between the surface and the air. Every variable in that equation matters. When dust, pet hair, kitchen grease, and lint accumulate on condenser coil fins, they create an insulating layer between the metal fin surface and the surrounding air. That insulating layer dramatically reduces the heat transfer coefficient. Less heat transfers from the coil into the room air per unit of time. The refrigerant, leaving the condenser, retains more heat than it should. It enters the expansion cycle, carrying excess thermal energy. The evaporator coil cannot absorb as much heat from your food per cycle because the refrigerant arrives already warmer than designed. Your thermostat detects that the cabinet temperature is not reaching set point. It signals the compressor to run longer. The compressor runs an extended cycle, drawing rated current for a longer period than designed. Then it cycles off, and the cabinet temperature rises faster than it should. because the refrigeration effect per cycle was reduced. The thermostat triggers another cycle sooner than designed. Your compressor runs more cycles per hour than its engineering specification intended. More cycles per hour means more current draw per hour. More current draw per hour means a higher meter reading. A higher meter reading means a higher bill. Energy Star laboratory testing of refrigerators with artificially induced condenser coil fouling documents. Compressor current draw increases of 15 to 35% at fouling levels consistent with 2 to 3 years of normal. Household dust accumulation. At 35% excess current draw, a refrigerator rated at 400 kilowatt hours per year is actually consuming 540 kilowatt hours annually. The copper fin comb clip addresses the second component of coil degradation. Condenser coil fins are thin aluminum flanges spaced closely together to maximize surface area for heat transfer. Physical contact vibration and cleaning attempts with brushes bend and flatten those fins over time. Flattened fins reduce airflow through the coil, reducing convective heat transfer independent of fouling. A fin comb tool straightens bent fins back to their designed spacing, restoring the designed airflow geometry and the designed heat transfer surface area simultaneously. The combination of cleaning and fin straightening restores condenser coil performance to factory specification. Your compressor returns to its rated cycle length. Your current draw returns to its rated value. Your electricity consumption drops to what the Energy Star label on your refrigerator actually promised when you bought it. Let us calculate exactly what the missing maintenance card has cost you. The average American refrigerator is 9 years old. At an efficiency loss of 25% from condenser coil fouling accumulated over 9 years, a refrigerator rated at 400 kilowatt hours per year is consuming 500 kilowatt hours annually. At the average U.S. residential electricity rate of 16 cents per kilowatt hour, that is $16 per year in excess electricity consumption per refrigerator every year. That number sounds small until you multiply it by 9 years of accumulated fouling and factor in the compressor damage. Over 9 years of excess operation, your compressor has experienced elevated operating temperatures during every extended cycle. Compressor motor windings running above designed temperature experience accelerated insulation degradation. Bearing surfaces running with elevated thermal load experience accelerated wear. Refrigerant seals exposed to higher operating pressures experience faster deterioration. The refrigerator that should last 22 years now has a realistic service life of 13 to 15 years. The $1,800 replacement you will purchase 7 years early traces directly to 9 years of running a compressor against a coil that nobody told you to clean. $1,800 early replacement cost plus $144 in excess electricity over 9 years equals $1,944 extracted from your household by the removal of a maintenance card that cost less than a cent to print. Across 130 million American households, each with an average of 1.2 refrigerators, the annual excess electricity consumption from dirty condenser coils totals over $2.5 in billion every year. Billed to consumers for wasted compressor cycles that a $3 fin comb and a vacuum cleaner would have prevented. Let me tell you who already maintains condenser coils as standard practice. Every commercial refrigeration installation in every supermarket, restaurant, and food service facility in the United States follows a mandatory condenser coil cleaning schedule. The reason is not energy savings. It is health code compliance. Commercial refrigeration equipment that fails a health inspection because of temperature excursions caused by dirty condenser coils generates regulatory fines, food spoilage losses, and potential facility closure. Commercial operators clean condenser coils every 30 to 90 days without exception. Every hospital food service operation maintains refrigeration condenser coils on a strict scheduled maintenance program. Patient safety requirements mandate that food storage temperatures remain within specified ranges at all times. Coil maintenance is non-negotiable in any healthcare food service environment. Hotel and hospitality facility engineers include condenser coil cleaning in their preventive maintenance schedules for every refrigeration unit in every guest room, minibar, kitchen, and food service area. Large hotel chains with thousands of rooms track coil maintenance completion rates As a key facility management metric, data center cooling systems, which use refrigeration cycles identical in principle to your household refrigerator, maintain condenser coil cleanliness as a critical infrastructure requirement. A data center with fouled condenser coils risks cooling system failure that can take down servers worth hundreds of millions of dollars. Coil cleaning is performed on quarterly schedules without exception. The supermarket operators know. The hospital engineers know. The hotel facility managers know. The data center operators know. The only people whose condenser coils have never been cleaned are the homeowners whose appliance manufacturers removed the maintenance instruction from the owner's manual 30 years ago and quietly waited for the replacement. Saleh, here is exactly what you need and exactly what you do. You need three things. A condenser fin comb, also sold as an AC fin comb or coil fin straightener, available at any HVAC supply store or online for $3 to $8. A vacuum cleaner with a brush attachment, and a flashlight. That is your complete supply list. Step 1. Unplug your refrigerator from the wall outlet. This is non-negotiable. You are working near the compressor and condenser fan motor. Always disconnect power before any appliance maintenance. Step 2. Locate your condenser coil. On refrigerators manufactured before 2000, the condenser coil is typically mounted on the back of the unit as a visible grid of black tubing and fins. On refrigerators manufactured after 2000, the condenser coil is almost always located underneath the unit, behind a snap-off or screw-off grill panel at the base of the front. Use your flashlight to identify it clearly before proceeding. Step 3. If your coil has a snap-off grill, press the release tabs and remove it. If it requires a screwdriver, use a Phillips head to remove the 2 to 4 screws securing it. Set the grill aside. Step 4. Use your vacuum cleaner, with the brush attachment, to remove accumulated dust, lint, and debris from the condenser coil surface. Work methodically from one end of the coil to the other, using gentle strokes parallel to the fin orientation. Do not press hard against the fins. You are removing surface fouling, not scrubbing the metal. Vacuum both the front face and the accessible sides of the coil assembly. If your coil has a condenser fan, vacuum the fan blades and the fan housing as well. Step 5. Use your flashlight to examine the fin condition after vacuuming. Look for areas where the thin aluminum fins have been bent flat or crushed together, reducing the airflow channels between them. These will appear as dark, compressed areas compared to the uniform parallel channels of undamaged fins. Step 6. Select the tooth spacing on your fin comb that matches the fin spacing of your coil. Most residential refrigerator condenser coils use fin spacings between 8 and 14 fins per inch. Run the fin comb through the damaged areas with gentle, consistent pressure parallel to the fin channels. The comb teeth will straighten the bent fins back toward their designed geometry. Work slowly. 1 pass is usually sufficient for minor bending, 2 passes for more severely crushed areas. Step 7. Vacuum the coil one final time to remove any debris dislodged by the fin straightening process. Step 8. Replace the access grill. Plug the refrigerator back in. Step 9. Listen. Within 15 to 20 minutes, your compressor should complete its first full cooling cycle. A compressor running against a clean coil sounds different from one fighting a fouled coil. The cycle will be shorter. The compressor sound will be slightly quieter. The click of the thermostat ending the cycle will come sooner than you have become accustomed to hearing it. Note your electricity meter reading today. Compare your next monthly bill to the same month from the previous year. The reduction will be measurable on your first complete billing cycle. Repeat this maintenance every 6 months. Set a reminder on your phone for every April and October, twice a year, 12 minutes each time. That is the maintenance schedule Charles Kettering specified in 1929 and the appliance industry removed from your documentation in the 1970s. One important note: if during your inspection you notice oil stains on or near the compressor, hear unusual grinding or clicking sounds from the compressor during operation, or observe ice formation on components that should not be iced, these are signs of compressor or refrigerant system issues that require professional service. Condenser coil maintenance addresses efficiency loss from fouling. It does not address mechanical or refrigerant system failures. If you observe any of these symptoms, contact an appliance technician before proceeding with any maintenance. Charles Kettering attached a cleaning brush to every refrigerator he sold. He was an engineer. He understood that a machine maintained correctly outlasts a machine left to degrade. He understood that the homeowner deserved to know what their appliance required to perform as designed. He put the instructions on the cabinet and the brush in the box because that was what honesty required of a manufacturer. Then the industry grew, and the accountants discovered that a refrigerator lasting 22 years was a refrigerator that did not generate a replacement sale for 22 years. And somewhere between Kettering's engineering philosophy and the boardroom calculation that followed, the cleaning brush disappeared from the box, the maintenance card disappeared from the back panel, and the access grille was redesigned to require tools that most homeowners did not own. Your refrigerator did not get worse between 1955 and today. The instructions for maintaining it simply stopped being included, because a customer who maintains their appliance is a customer who does not need to replace it on schedule, and a customer who does not replace on schedule is a customer who generates no replacement revenue. The Fincomb costs $3. The cleaning takes 12 minutes. The electricity savings begin on your next billing cycle and continue every month for as long as you maintain the coil. The compressor lifespan extension is measured in years. The replacement cost you defer is measured in thousands of dollars. Charles Kettering gave you the maintenance schedule in 1929. The industry removed it in 1975. And for 50 years, 130 million American households have been paying the electricity surcharge and the early replacement cost that the removal of a maintenance card made possible. Now you have the schedule back. Your appliance maker has a problem. Subscribe to Forbidden Saving and share this with every homeowner you know who has a refrigerator running right now that nobody has ever told them to maintain. Every share keeps this vault open. Every subscription preserves what the industry spent 50 years hoping you would forget. The next vault opens soon. What is inside costs even less and saves even more.